Hopefully this video will answer some of the questions you have about grading your FRQ. So jumping right in, we see that in a report to the Department of Transportation of a Western state, a large trucking firm stated that the distribution of weights of its fully loaded tractor-trailer trucks is approximately normal with a mean of 19,016 pounds and a standard deviation of 2,324 pounds. The state police decide to check a sample of 40 of the company's trucks to test the company's claim concerning the mean weight and standard deviation weight of its trucks. So right away, when we look at this problem, we're thinking, okay, it's probably something to do with populations and samples, and then eventually our sampling distribution. We know that the population in this problem is this large trucking company's firm, and then we're looking for our parameter would be the mean of all of their trucks, and then we're taking a sample and trying to find out what that statistic is. Part A is asking us to assume that the company's claim is true. So their claim is that their mean weight is this 19,016 pounds. So describe the distribution of the sample mean weight for random samples, each consisting of 40 trucks. Basically, what this is asking us is describe the sampling distribution. The three things you need to state to get full credit for Part A would be to state that this sampling distribution is approximately normal, that it has a mean of 19,016 pounds. If you don't have units on it, that's okay. Just try to remember units in the future. And that our standard deviation is, you can leave it in this form, this 2324 divided by square root of 40, or you can go ahead and simplify that down to 367.46 pounds. We get this standard deviation because we take the standard deviation of the population, which is this 2,324 pounds, divided by the square root of our sample size. Our sample size is going to be 40 trucks. As long as you have these three statements, you're good to go and you would get full credit. But just like as a reminder, we know that our sampling distribution is going to be approximately normal because we're using the central limit theorem. Since 40 is greater than 30, we can say that the central limit theorem states that if the sample size is large enough, our sampling distribution will always have an approximately normal distribution. We also can say that the mean of our sampling distribution is the same as the mean of the population because we're assuming random sampling, and therefore we won't have bias and we will have an accurate sample size. We're also assuming that we know that 40 trucks, or we're assuming that 40 trucks is less than 10% of this whole company's population of trucks. So those are our three conditions that we've been talking about. Those are all met. You don't have to specifically state those, but that's just where the logic of this problem is coming from. And then moving on, part B is asking us what is the probability that a random sample of 40 of these companies' loaded trucks would have a mean weight of 19,168 pounds if the company's claims are true. So for this one, to get full credit, you need two things. You need the proper answer, 0.34. If you have more decimal places, that's okay. Also, if you've written this as a percent, 34%, that is also okay. And you need some sort of justification. So you either need to calculate the z-score and show our z-score calculation, or you can show your calculator steps that you're using a normal CDF distribution, and then you have your lower limit, your upper limit, the proper mean, and standard deviation. If you answered this problem with an incorrect standard deviation, so say instead of using the standard deviation from part A, you use this standard deviation from the original problem, 2,324, everything else is correct, so you have your proper justification or work, then you'll receive partial credit on part B. If you only have work and no supporting work, if you only have the answer and no supporting work, then part B is incorrect. Now, just some logic from this problem. We know that because our random sampling distribution has a normal distribution shape, then we can use our normal curve. So we know that our mean from part A is this 19,016 pounds, and we want the probability that what the sample found, which was this 19,168 pounds, what is the probability of our mean weight being that value or greater? That's why we're using our normal CDF, and that's the justification for it. Question C is really asking if you understand why it's important to have a random sample. And we need a random sample in order to have that accurate mean, in order for the mean of our sampling distribution to be the same as the mean of our population. We need our statistic to make an inference about our parameter. If we're scoring part C, you need two things to be fully correct. First, you need to indicate that just sampling the first 40 trucks is different than sampling the trucks in a random way. So maybe the first 40 are lighter because when the trucks come out, they're not fully loaded. But you need to give some thing that indicates that these first 40 trucks are different and may not represent all the trucks as a whole. If you use the words bias or inaccurate, that's good, but you have to give some sort of reason that relates to the context of the problem. So if you just said that non-random sampling results in bias, that's the right track, but you need to take that further with the context of the problem in order to get points. All right, the last thing you're going to do is score yourself on a scale of 1 to 4. So 4 means all 3 parts were essentially correct. 3 means 2 parts were essentially correct and 1 part was partially correct. You get a 2 if either 2 parts were completely correct and 1 part was incorrect, or if 1 part was totally correct and 2 parts were partially correct. And then anything less than that is a 1, and then a 0 would be nothing is done.